Welcome to Spring LIB.
This is a question that actually requires a graphing calculator. So I don't have a calculator to show you guys, so I would just try. So I'll just try to draw this question as best as I can, but this is a question that is supposed to be done with a graphing calculator. So we are given a couple numbers. We are given a equals 0.15 meter, k equals 3.5 per meter, plus or minus 1.8 t. So this is d. And in part A, we chose t to be 1 second. So this would just be 1.8. So this is the expression you should put into your calculator. But we also say we want to have at least one wavelength. So it doesn't hurt to try to find the wavelength. The wavelength is 2 pi over k, which is 2 pi over 3.5 per meter, which is around 1.8 meter. And that is the wavelength. Draw the graph. Setting the x on the graphing calculator sets the x maximum to be at least 1.8. And the amplitude we would expect to be 0.15 and negative 0.15. If you have the calculator, you will see that the actual wave looks something like this. So this is for D2, which is the wave with the plus sign that is traveling to the left. And for the wave with the minus sign, D1, this is D1. So this is D1, which is a wave with minus sign that's traveling to the right. And we also have D2, which is a wave with a plus sign that's traveling to the left. And that will look like something like this. So you can see that compared to a normal sine wave, will look like this. This is roughly, it almost looks like it's shifted by around 1/4 of a wavelength. And that is because if we look at this, we can see that 1.8 is around half of x. So that is to say, by introducing this extra time of 1 second, it's almost equivalent to moving x to the left or right by roughly 0.5. And 0.5 is roughly 1/4 of a wavelength. So it's like it's a normal sine wave, except that it's shifted to the left or right by a little bit more than 0.25, 1/4 of a wavelength. But anyway, that is part A. And we look at part B. The part B asks us to plot the sum of the two waves and to identify the node and antinode of the plot. Okay. So we can see that if we add them up, we will get something like D equals, the amplitudes always add up. And we have sine kx, which is 3.5x, and cosine omega t, which we already have, is 1.8. This is a mathematical expression of it. And if we plot it, we will have the amplitude is larger, 0.30, negative 0.30. The wavelength also does not change. It's also 1.8. But here, so as I said, it's since it's a standing wave, the node and antinode does not move. It is it's standing there, it's stationary. So the cosine, when we have t equals 1.8, it becomes simply part of the amplitude, and this will be a standing wave. And the actual amplitude is 0.3 times cosine 1.8. And as time goes by, what happens is that this amplitude might increase until it reaches 0.30, and then it will decrease, and this pretty much just vibrates with the same node and antinode. And the question says we need to find the place of the node and antinode. So we can find out using the expression x equals n pi over k. So that gives us 0, 0.9, 1.8 is the place of the node. And the antinode is in the middle of these. So for antinode, we will have x equals 0.45 and 1.35. And we can see that is exactly what we get in the graph.